So remember that there's 3 different ways to create a VM. It's via the console, via the command line in the Cloud Shell, or via the REST API. So one of the other factors you may want to consider is that when you create a VM, if you need that VM to be mobile or to support a specific capability, like you need a specific amount of compute power, or you need a specific processor type, you need to look at what is available in that zone. So for example, let's say you're creating a real IOPS intensive application, and that application really needs to have so much compute power. And if you select, like, for example, the wrong zone, for example, and remember a zone is going to be, so just think of a zone again as sort of what is in a region. So a region is basically comprised of different zones. Now, most Google regions comprise at least of 3 zones, so just be aware of that as well. So depending on the platform that is available in that zone, you may or may not be supported, let's say, in another zone. So just correlate that, cross-reference that. So if you create an instance in US Central 1, you might be using this type of processor, for example. So again, just be aware of that. In most cases, it's not going to be a big deal, but there is always that possibility where you might have dependencies for specific requirements. So just, again, attention to details. And so if you look at the map here, or actually the workflow, you can see that you have mobile devices using Cloud DNS. They're load balanced as well, as you can see, and each of these compute engine instances serve its own purpose, and it also appears that they're part of a scaling group as well. So there's 2 types of instance groups in GCP. You have managed and unmanaged groups, and we'll talk about the differences between those. Now, let's say, for example, if you have 10 virtual machines, then those 10 virtual machines you could put into an instance group and manage them as if they're all, one virtual machine essentially. And so it helps you scale and manage those resources effectively. And that's essentially at a high level what a managed instance group is. But what about if you have different virtual machines? Let's say this one here is a Sandy Bridge processor, and this other one here is another processing type. Then those would be considered 2 different configurations. And so you might need to look at what's called an unmanaged instance group. And we'll talk more about that here in a minute. So a managed instance group is going to use more of a template approach. Now, another thing too, when you create instance groups, that you can also use those for migration, aligning assets, scaling, and recovery. And there's 2 types of managed instance groups. So remember, we have unmanaged and we have managed instance groups. But managed groups also has 2 different types. One is a zonal, one is regional. So a managed instance group is essentially a template that you're going to use to create or update the instances that are part of that group. So if you make a change, that configuration is propagated through that whole group. So an instance template is a global resource. Now I know, again, some of this may not come totally together. We're going to put it all together here in a minute. But remember that if you create VMs here, there might be a chance you might want to move them somewhere else. And again, you want to create an instance group typically to manage configurations, to manage failover, auto scale, etc. But what about if you don't want to use a managed instance group? You don't have to. Again, you can individually manage all your VMs as well. That's your call. Now, by default, that is, instances in the group will be placed in the default group and will be randomly assigned IPs from that range, from the regional range. So, for example, all those IPs will essentially be assigned IPs that will meet the requirements of that region, essentially. And then an unmanaged group is different in the sense that you have dissimilar instances. So again, if you have this VM with this config here, and then you have another config over there, well, those VMs may not be managed because, again, the configuration could be different. So if you have a different configuration on the left and a different on the right, you could put them in an instance group for essentially, for visibility purposes, but it's not going to have the benefits of a managed group. That's really the main point. So for example, auto scaling isn't there. Rolling update support isn't there. So use managed instance groups only if you need to apply load balancing to your pre-existing configurations or to groups of dissimilar instances. And that just basically says that when you put it in an instance group, you could apply load balancing, but the reality is that's all you can do. You can't auto scale. So let's say, for example, you need additional resources added to those VMs. It's not going to do that. And then we have what's called rolling update. Now, rolling update is where Google, when they update the infrastructure, they go basically one rack to another, essentially over and over, and that's called a rolling update. So you get your turn eventually, and the question is how is this handled? With the unmanaged instance group, there's no support for that. So there'll be some manual upgrades that may need to be done down the road. Now, as far as virtual machines are concerned, just remember that you could use a templated VM, a pre-built virtual machine, or you could use an image that you create. That's your call. So the image that you use, whether it's from Google or Google Partner or from your own, will need to have typically a bootloader, an operating system, a file structure, software, any customizations that you need, and typically will be a tarball or gzipped, and it will be managed by Google's image service. Now, the different types of images in Compute Engine, you have public and private. So the public is going to be basically when you log in to set up a VM, you'll see that there's different AMIs that are available, machine images, I mean. Basically, those are public images. And then you have private and custom ones. That's where you create a new image from a VM that you've already got created, let's say, or you import it from on-prem or another cloud also. And then some of the management features as well could be around image sharing or image family development, or what's called deprecation, essentially. I knew I said that wrong. Again, that's up to you, where you essentially depreciate that image over time. And depreciate means that the value of that gets, less important over time. Now, images could be utilized from VirtualBox or from AWS, and those images would be stored in cloud storage. When we talk about Compute Engine, we want you to understand that, again, Compute Engine has different configurations available. And so there's different images, different boot processes that you could use. So for example, when you shut off a VM and you bring it back up, you could configure that virtual machine to boot off a specific image if you so choose. That's your call. Could also attach a persistent disk as well. That's a very expensive approach, but you can if you really need to have that performance met for whatever purposes. Now, each persistent disk can be up to 64 terabytes in size, so there is no need to manage arrays or anything like that. So that's one of the benefits as well. These are the different disk options. Now, again, it sort of comes down to the fact where you can go and, pay for a car, right? You get the car that fits, 14 people in it, a van or something, or you get a car that fits 2 people but has an engine that's twice as powerful as any other car. So if you need performance, you need to get the right solution to meet that. So persistent disk, hard disk, again, is good for your general workloads. Persistent disk is going to be more for random IOPS. That could be applications like, for example, that's transactional. High IOPS and low latency. This would be more for essentially what would be called not really mission critical, but production apps in a lot of cases. This is where you might have a database and you need to run queries and searches, and you need a response in a fairly predictable manner in most cases for that application. This might be a good reason. And then you've got RAM disk. Now this is again probably by far the most expensive. It's going to be low latency and again very low data loss capability, but again very expensive. Now you have what's called cloud persistent disk and computer hardware disk. Now, computer hardware disk is going to be typically attached to the server, so it's going to be more or less internal or connected directly to the hardware. Cloud persistent disk is going to be more of a file structure, and this is basically where you may want to use a persistent disk if you need to get a file structure in place, let's say. And so pay attention to the different use cases. Cloud persistent disk, again, you might want to use this for growing your file systems. Let's say you want to create like a network attached storage share, a NAS share. That might be a good use case. Snapshots. Now you create a snapshot for many different reasons, but generally you want to create a snapshot for keeping a point in time recovery. It creates an incremental backup to GCS, and you can restore those snapshots back to whatever machine that you're taking that snapshot of is, or restore it to another VM as well. Now, you don't want to use this typically in a database migration solution, especially if you're going between zones, just because of the fact that you could run into a lot of what would be called performance and persistent issues as well. And it's not supported with local SSD. Now there is 2 ways to move a virtual machine. You can do it manually or automatically. And a lot of it does come down to support availability. like I was saying earlier, a lot of it just depends on where that VM is and where it needs to go. And if you are in a supported zone with that VM and you're going to go to another supported zone, then that VM could be automatically migrated or moved. But let's say the source is perfectly supported, but the target isn't. Let's say you change zones or change regions. So again, just be aware that there's two ways to move a virtual machine. Now, you don't typically want to use a virtual machine with a local SSD. So you can't back up that SSD, and so that's one of the challenges. So anything that's kept on the local SSD is not going to be persistent between reboots. Now, persistent disk must be attached to the VM you're going to move, not to multiple VMs. So again, if you have a persistent disk, it can only be attached to one VM. It can't be attached to two, and especially if you want to move it. And then again, you need to validate that you have the resources in place to be able to move. So for example, if you don't have enough space available in your object storage, then you can't migrate the data. Or if you have quotas that restrict the amount of data that you can copy between regions or zones, then again, you need to pay attention to those little details. And so now, as far as App Engine is concerned, there's two different approaches to App Engine. You have App Engine Standard and App Engine Flexible. Now, generally the main difference is really what you need supported and how robust you need sort of like the customization to really be. So App Engine Standard, again, works with Java, Python, Go, and PHP. And then Flexible also works with Node.js and Ruby. So just pay attention to those differences. And then if you have a custom environment, let's say you want to run something that isn't listed here, this would be a reason to use App Engine Flexible. And this is a managed platform as a service. It's auto scale. So let's say, for example, your resources are running a little bit slow. Once you hit that sort of threshold, it'll add resources automatically. And what's cool about App Engine is you don't have to pay for using App Engine. You just pay for the resources that you use alongside of that, like the virtual machine or the bandwidth or storage. So Google App Engine is a platform as a service. It scales infinitely. Standard environment is fully managed, and it supports Java, Python, PHP, and Go. And again, make sure you know what is supported and what isn't. It is a very flexible environment, so you have a lot of capability around containers and also any kind of other languages that you need to support that may not be here as well.